So now move to the next techniques, which is boundary value. So first, let's see, why do we need the boundary value testing? When we say now, for example, we want to test the application from 0 to 10, I mean these variables from 0 to 10, and then we just maybe now, based on the partitions, equivalent partitions, we just say something is any number before, any number between, any number after 10. So suppose we select here -5, select here 4, we select here 20. Okay, so based on some studies, they show that most of the error it's come from the boundaries. Yeah. Okay, the errors come. That's why we here in this next slide will say why we need to do both. Why we need to do both? This is one reason, because the error is come from boundary. So maybe if we test now 4, but it's pass, but we have problem here when we test 0. When we test 0, so this is, we need another techniques, which is boundary analysis. The boundary analysis include the boundaries. So this is the difference. Okay, so as we see here, this is maybe some which is the idea of boundaries. So here you have also to check the boundaries of these operations. For example, if it's equal, so you should also you have to check that equals, also the number before, the number after. For example, if we see the number is x equal to 10, okay, like here, so we will not test only 10 only. No, we will test 10, we will test 9, we will test 11, because maybe the error will come from these boundaries. Okay, this is the difference, and this is actually is enhance of the equivalent partitions. Okay, so here these notations, if you see, when we have, it's as we say, okay, as I show you, it's this is the notation that is used for boundary value. So when we have, for example, now greater than or less than without equal, so here we have two value need to be tested. You will see an example. Okay, if we have equal, I mean greater than or equal, and less than or equal, so here we have 3 value need to be tested. 3 value. Okay, let's see here example maybe, and we skip the next slide. For example, if we say is greater than, x is greater than 10, so we have to test 10 and greater than 10. Okay, here if we say greater than or equal, so we have to test 10 and greater than and less than and equal. And equal, here we have only 2 value. 3 value, not 2. Yes, as I show you the example. So here, this is the examples. If we say is less than, so as I mentioned, we have 2 value, less than. So we test 9 as a less, and we test also the 10 itself. So the next, which is if we have the equal, so equal or less than, so we test the equal, which is 1, we test the less, which is 0, and we test the invalid, which is invalid. This is invalid 1, which is 2. So, and the same thing, it goes to this if it's just is greater than. Equal, also 3 we have, which is, this is true. This is should return true or valid, some as we see previously. This is the valid, and this is all is invalid. So the same example now, but also we include the boundaries now. We include the boundaries. So here, if you see here, when we have the greater than 10, greater than 100, greater than 100, so we include 2 value. This is greater than 100, so it will be the 100 itself and 100. So now if we test this less than or equal to 200, so also we include 3 value for this 3 value, which is 199, 200, and 201. Okay, this is the boundaries. I already explained this one, but we should also repeat again. Sometimes why we need, because we say the errors sometimes it's come from the boundaries. This is number one. Also, if we just want, for example, I will take only the equivalence partitions. For suppose I say, okay, why? I mean, if I say here from same example, 10 to 9, right? 10 to 9. So here I will take a number if I take only the boundaries. If I take only the boundaries, that means here I will test what? 0, based on the condition. For example, let's say I will take 0 or -1, 0, and after that 1. Here I will test 9, because here 10, okay, 10, 9, 10, and 11. So if I say, okay, since we say now the boundary is important, so why not boundary only? Why not boundary only? Because this is 10 and 9, for example, 1 and 9, it's already from the boundary, right? From the partition. 1 and 9, it's from the partition. Also here, when I -1 is from the partition, 11 is from the partition. So we have the invalid, we have valid, we have invalid. So why not? Why not only partitions? Because now we test only the partitions. We test only the partition. But how about the normal value, which is in the middle, the normal value? And this is what we say here. How about the normal value? So it's better to test both. Better to test both. So guys, okay, this is in quick because I think we take long time for these two topics. Yes. Yeah, this example, now why I give you this example, because I don't just want you to think that the partition or the equivalent partition and boundaries is only the numbering, So here, if we want to test, for example, ATM card, so this is the requirement from the SRS. Okay, this is the requirement. So this is, we have ATM card as an input. When you go to the ATM machine, you will put your ATM card. So ATM card here, how we can test it, for example, in partition testing, how we can divide the ring of the partitions of the ring of the ATM cards, the type of the ATM cards into partition, into valid and invalid. Okay, your ATM card. How we can, if I told you this is, we need now the partition. What's the valid and invalid partition based on this question for ATM card? And here we say it's okay, just ATM card. Guys, what's the answer? Hello, guys.
Yeah.
Yes, you see, guys, we take many examples now for dividing, divide the ring of any input into valid and invalid. And this is the idea of these two types of testing, which is the equivalent partition or the boundary values. So now if I have an ATM card, now this is not the first one I'm talking about, only ATM card. How I can divide these ATM card into valid and invalids? What do you think? Just give me your opinion. You have ATM card, okay? How you think this is valid to be used in the ATM machine?
The size.
Okay, the size and many things, right? So at least you have two partitions and you divide it as you want. But let's say think like, okay, wisely. So the first one we say invalid, right? Invalid, and then you will put sum of invalid card. So, and then valid, and then you put the valid card. Okay, so invalid, what kind of invalid cards? So let's say first the valid card. First card, which is any, for example, any Visa card, any bank card, any type of card is issued by the bank for withdraw money or for using in the ATM. You can list some, which is valid, for example, because you have to define what's the valid here. Okay, so invalid, any other card, for example,
Library card.
Yes, for example, your card, ID card, your person, your for example, TV card, many things, many cards. many cards, it can be this is invalid. For example, let's say, okay, ID card. And this is the valid one, which is Visa card, MasterCard, anything. So just guys, I don't from this example, not only numbering there, anything is also can be divided into valid and invalid, or can be tested using these techniques, which is partition testing. So the second one here, the bin number. Okay, here in Finland it's 4 bin number, but okay, this is 6 bin number. So what's the kind of valid? You see here, guys, we have only 2. We have only 2. I think we don't have 3 partitions. We have 2. Okay, you can, for example, in this example, we say, okay, 2, maybe your opinion is different, and you say, no, I have 3 partitions. But here, I think it's 2. So for the bin number, what do you think? How many partitions we have? Since we say here the partition or the bin number is 6-digit input. 6-digit input. Okay, this just
3 partitions.
Maybe yes, I think it's 3 because we have 6. So let's say okay, maybe we have partitions with valid, which is 6-digit. 6-digit, yeah, 6-digit. We have here any partitions is less than 6-digit. For example, if we say here the digit, 0-digit, right? Maybe can be like this. Okay, yes, here 6. So we have the bins is someone is maybe key in only 4 digits, 5 digits. No, less. So they have 6-digit. Okay. So will be here is any number is less than 6-digit. And here, this is the 6-digit. Yes, this is the 6-digit. And here we have less than 6, and here is greater than 6. Yes, it should be like this. Invalid, which is any digits, for example, 5 digits. And then here it's more than 6-digit, and here the numbers between them. So here you can test later also with the partitions or with equivalent partitions. So it's both is accepted. But here, okay, the numbers, for example, here any numbers from here it can be accepted. Here we don't say, guys, from 0 to 6-digit. And here if you have 4-digit, whatever, for example, it's 9999, for example, is 4 digits. Or maybe it's 5 digits, any number, not only 9s, any numbers. So these we can have here, invalid, valid, invalid. Okay, maybe we go to the next now.